All right, Professor Cooper here for data visualization again. We're going to talk about animated plots, and we're going to be using the gganimate package. And this is part of the tidyverse. It is not one of the sort of core pieces of the tidyverse, but it's part of the tidyverse. So let's go ahead, and this is probably going to take a couple of videos because there's a lot going on. Let's load some data, and then we'll make a couple of plots, and I'm going to talk about some things about the key features, right? So basically, the way this is going to work is we load tidyverse, we load gganimate, we load some data. gganimate actually isn't the only package that does this. Magic is another package that can do this, and Magic will be useful in other ways as well. The Magic package for things like GIFs, but it can also do its own animations, which are essentially GIFs depending on whether or not you choose to render them that way. But in gganimate, there are a few key features that provide the functionality for gganimate. The first is the transition, and this is the most important, I would say. The transition is going to define what is being animated over. Okay, so often it'll be something like time in years, maybe, or the different states of or groups of a particular variable. So we are going to really focus on first the transitions. So we've got a few choices, and here's how it goes. You set up a ggplot, pretty much like you would have anyway, a static version of it. And then you're going to add some extra code onto the end that's going to turn it into an animated plot. And it starts with the transitions. So we have transition states, transition reveal, transition time, and transition manual. And these are all slightly different. Transition states, it's kind of like a faceting in a sense, but it's faceting within one panel. And really, it's just chopping it up into the categorical states of the variable that you cite in the argument. And you can calculate some transitions in between. This is not entirely accurate. It's sort of context specific. Transition reveal, time, and manual are different forms, especially for transitioning over time. Some of them, they allow nice, what's called easing, or sort of calculation of movement between the transition. Tweening, as it is called. And we're going to talk about that next. So there's something called easing. What easing does is it calculates how the transition is made, including its sort of velocity and shape and speed. So if you've got an observation at time point 1 that's in a particular location, and then that same observation at time point 2, a different observation but the same unit, right? Same person, same country, same whatever. And what the easing does is it calculates a smoothed transition from the first point to the second point. And it allows you to apply some interesting little functions, some interesting little mathematical functions that can determine how it actually makes that transition. You can make it bounce. You can do a sort of a circle or a half circle. You can make it kind of quote unquote elastic. You can do sort of a back and then forward. It's got quadratic, cubic, quartic, sine and exponential functions to help define how it smooths that transition. And then you can add in, this is all in an ease underscore AES line. So it gets its own line. So transitions get their line. Easing gets a line. Then later on, enters or exits, if you choose to use them, will also get a line. Could get multiple lines, actually. the in or the out determines whether or not the algorithm is defined for going forward or in reverse or both. So you can take a function and actually make it go in forward and then reverse from one end to the other, depending on if you say, for example, cubic in or cubic out or cubic in out or something like that. So there are some combinations that you can play with, and you can see how those transitions, those easings are made between the states. Now, you should use easings when you are connecting like units, maybe across time or something like that. But it's not really the best idea to, let's say, I transition from one region in Europe and show their income inequality scores in points in space, and then switch to another sub-region inside Europe, right? Because then if you make a transition and you actually make the point move from one point to the next, you are implicitly suggesting that there is an actual connection between the two observations, and there isn't, right? We're talking about maybe, you know, Moldova or, you know, Estonia or somewhere, and then all of a sudden we're talking about Denmark or Spain, but those points get connected potentially if you create an easing between some points. So it's not necessarily the case that that's a good idea. And if you have a grouping variable, it overrides it anyway, so it's not a big deal. But conceptually, it should make sense that if the easing represents a transformation, a visual transformation between one observation to the next, from sort of state to state, from time point to time point, at least, that it's not the best idea to necessarily jump units or jump observations or jump groups, right, when you're doing that. But there are a lot of examples to play with. I'm not going to cover all of them in this particular video. All right, let's talk about enters and exits. They're very self-explanatory. They get their own line as well. So as you're setting up gganimate, you will have the transition line. You will have an easing, an ease underscore AES line. And then if you want to sort of define how the enter and the exit happens, you might have multiple enter or exit lines. You can make it shrink as it leaves. So it can, you know, let's say you have a scatter plot and you have a bunch of points. You can use an exit shrink and it will make the points just disappear. You can make them fly away, in quotations. You can just make them fade. So instead of shrinking, they just sort of disappear slowly. You can make them drift. So it's a combination of fly and fade, if you will. You can have the colors phase out and shift. There's a lot to play with there in terms of the types of enters and exits that you can use, just like there's a lot of options for easing. So I encourage you, once you see a few examples, to sort of go look at the other options and sort of play with it to get your head around the kinds of things that are available to you. Labeling. So it should make sense that if you have an animated plot, in theory, you would also want something like an animated title. You would want either an animated title or maybe an annotated subtitle. So you could say, if you're showing all the countries in Europe in their income inequality, individual frame by frame or state by state. So each individual nation gets its own panel. Then you might have a main title that says something like income inequality in Europe, according to the World Income Inequality Database, blah, 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 WID. And then in the subtitle, you might actually say the country, right? Or the UN region, or whatever the unit happens to be. So you can do this where the animate transitions that label in the subtitle along with the state being transitioned. So that's good. It'll come in the form of braces inside the title. It'll come in curly braces, and it'll say something like closest state. If you're doing transition states, you can do the previous state, you can do the closest state, or you can do the next state. So it can be state minus one, it can be the state that is currently being shown, or it could be state plus one in a sense. Now, the rules for how to write this particular piece inside the braces depends on what kind of transition you're using. If it's a transition like manual or reveal or time, it's a little bit different. You'll usually cite like year or something like that in there instead of state. But the basic setup and the basic syntax is the same. Okay. Again, finally, to repeat myself a little bit on this particular video before we get to the first example, group aesthetics here are going to become really important. So like maybe fill or color aesthetics that set up, you know, or maybe even year, I guess. That could be one. Group aesthetics are going to help define the transition, whether it's discrete, whether it's not. You know, if you're working in time, that's going to be an important thing. But it will override, like, you're not going to be able to really, if you set up a discrete grouping variable and then you think, hey, incorrectly, I should say, that you want to add an easing to that, the group variable is basically going to override the easing and it's going to take care of it for you, but you should know that that's what's happening. It's one thing, again, it's one thing to animate, just don't animate across different observations. That just sort of makes an implication that is not really accurate. You know, but again, the appropriate grouping aesthetic might take care of that for you. So you might have an accidental incorrect piece of code, but you might not know that it's not working correctly because the grouping aesthetic might take care of it for you. All right, so let's get to an example. I'm going to show you one example from the MT-Cars database. I've used this data set and this example a bunch. So I'm going to make a factor for cylinders from the MT-Cars database. And then we're going to set it up just like it's a scatter plot, right? So we've got ggplot, aesthetics, weight, fuel efficiency, and we're going to make color be the grouping variable. So this is a discrete grouping variable for the cylinders of the engine. So it's 4, 6, 8 are the available categories here. We have our scatter plot. Then I set up a theme, and then again, like I said, like this is all just a scatter plot. This is the basic scatter plot right now. Now we're going to keep going. We're going to add a plus, and we're going to have a transition state. So the transition states is that particular line, that function in ggplot, is defined by the grouping variable. And then we're talking about transition states and length. This actually depends on what you're doing about the relative length of how long it's there, whether or not it's actually going to be useful. I'll show you what it's like without that to start, actually. And then I have some other examples so that I can show you what happens when you use them. Let's see. Let's actually just kill all of these right now, in fact. And let's just run it as is. All right. So we're going to just run it a base transition states, and that's it. And I'm going to stretch it out. And you're going to see this rendering situation happen here. Okay. So that's going to tell you how long it's going to take for this animated plot to render. It really ends up rendering, right, a number of frames. And the number of frames depends on how many states there are. And then eventually, when we get down to the nitty-gritty details about how to render the animate using the animate function, that'll come, I think, in the second video, and then saving it, we can actually add how many frames per second we want so that we can make the transition as smooth as we really would want to, probably smoother. Because you can add a bunch of frames per second and then it becomes a very smooth transition, but it can take much longer to render. Okay, so the framing has completed, and you can see what's happening here. There's no real transition between the states, which is good because the 4-cylinder engines do not morph into 6-cylinder engines and do not morph into 8-cylinder engines. Notice that in the viewer window, it is a little bit fuzzy. That's not anything to worry about. Once you animate and you save this outside and you render it as either a GIF or like a movie file or something like that, it's not going to be like that. And if you were to render it in HTML, you would be able to see immediately that it is crystal clear. I haven't done anything to any of the labels, as you can see, but this is what the transition looks like. And, you know, in this case, you might actually, I don't know, speed it up just a hair. You can do this in the animate and in the when you animate the plot and then you save it, you can actually change sort of how quickly this happens, right? What's the duration of each of the entire thing? How many seconds is this going to last? And you can divide up how many seconds happen and show each state. Okay, so this is a basic one. So let's kill this. I'm going to kill that, and then I'm going to add a few things to it. I'm going to add the wake is actually, this is actually not helpful because this is for when you actually do have an easing. I don't know. I think Siri just thought I was asking something. Okay, so let's do an enter fly. And let's do an enter drift. Let's start with an enter fly and an exit shrink. Okay, I'm just going to add an enter and an exit, and I'm adding enter fly. And you see X location -1. This means it's going to fly in. This should fly in from the left, and then it should just shrink away. So we'll let it work here a second. Again, this particular one is on transition states, so it's a categorical variable that we're transitioning on. And so the easing is not, this thing is not a thing that we should even be using. Okay. Give it just a few more seconds. And then I'll show you a couple more examples and talk about the finer points of animating and saving in the second video of this little series on animated plots. Okay, you can see the difference. So the points literally fly in, I suppose figuratively fly in. They come in from the left, from the X location, -1, that means come from the left. If I switch this to +1, it's going to come in from the right. Exit shrink means just what it sounds like. You can see the points don't just like disappear off the map, they kind of shrink away, right? So that's interesting. That's a nice way to animate it. So you can actually change the Y location as well. So you could do X location plus Y location, and it's according to sort of the scale here. So you could add some crazy drift. Like if we add some drift here, we'll get some weird things. I'll do this one more time on this one, and then I suppose we will start the next video on the next iteration. So I'm adding some drift, and I have +5 and +20. Let's see where that takes us. In theory, well, I should actually, there's some conflicting, the X and the X location and the X modification and enter drift are slightly competing, but it'll be okay. It should end up producing a similar result. Let's see what happens. Okay, so it does kind of, that's interesting. That's actually interesting. Okay, so if that x location equals -1 wasn't there, we'd essentially be coming in from the top right corner, and we'd be drifting in. Okay. Instead, that -1 pulls it over a little bit, and so we're kind of coming from the top and we're spreading out, and that's kind of interesting actually. So you can play around with this and find a modification for this kind of drift and fly-in sort of effect that meets an aesthetic standard for you. But these are all the different kinds of things that you have available to you. And the exit is still working the same, right? Okay, so let's see. I think we are going to stop this particular video, and in part 2, I will continue this conversation, showing you some more examples, talking about how to save this as an object before you actually animate it, and then you can sort of manipulate the duration of the animation and do things like that, and also render it in different formats.